Hi, I'm Dr. Shmuel Kliger, a founder of Causal.io, and you are listening to the DiscoPosse podcast.
Fantastic. Do you know how many years I've been waiting for us to be able to do this? And I don't know how we haven't done it up to this point, but Shmuel, thank you and welcome. Holy moly, this is really great to catch up, and I'm excited to be able to share your story and the Causal story today.
And I'm excited to be here with you.
So, Shmuel, let's start for folks that are new to you and new to Causal. I want to get you to introduce yourself and tell your story. We'll talk about obviously the challenge that Causal's solving, and you and I luckily have had an amazing. I've been lucky enough to spend a lot of years learning from you in the industry and in what we were solving together when we were both at Turbonomic, and I still remember sitting in a hotel lobby in San Francisco, meeting you for the first time many years ago at a VMworld, and here I am, and I have to say, first of all, thank you, because an amazing amount of what I have today in my life is genuinely because of what you and everything that was around you gave to me. So I am very grateful to all the opportunities that, whether you realize it or not, you created for me and for many others.
Thank you. And it was always a pleasure to work with you. As you know, I always was looking for believers in my preaching, and and every time I came across someone like you, I got excited. So, and it's good to reconnect after a few years after we left Turbonomic. Yeah. So let me start by giving my background, because I think it's very relevant to Causal, because to some degree Causal is just a continuation of what I did for a few decades. So so before Causal, I was the founder of Turbonomic. We started Turbonomic in 2009. We were focusing on application resource management of applications running in virtualized and cloud environments, managing those environments, making sure that the application gets the resources that they need in order to perform when they need them. And we were acquired by IBM at 2021. A very successful outcome there. Prior to that, I was a CTO at EMC, the CTO of the Resource Management Software Group. I arrived to EMC in 2005 as part of an acquisition of a company called Smarts. We started Smarts, I was the CTO at Smarts. We started Smarts in 93. We became the leading providers of root cause analysis, focusing on networking, and we were acquired in 2005 by EMC. Prior to that, I was a researcher at IBM. I arrived to IBM to do my postdoc. I did my postdoc my PhD in compilation of logic programming, concurrent logic programming languages, which were the foundation for, if you want, for AI in the first hype of AI in the late 80s. And if you go back to where I started my career as a system programmer on mainframes in the Israeli army. And the reason I'm going to this history, my background, because it's, if you think about what I did in the 70s in the Israeli army, on mainframe, managing systems on mainframes, and how we operate environments today, it's kind of nothing changed. I mean, the world changed, the technology changed, we have better UIs, but fundamentally, we are operating environments in a similar way in which we collect a lot of data, we analyze that data, we provide this data for human, and we let the human make decisions of what needs to be done in those environments. And that's what we did with much worse user interfaces in the 70s, but that's what we are doing today. And if you look at my entire career, especially after my PhD, both at Smarts and Turbonomic, it's focusing on that part of the IT operation, trying to build a system that can actually make intelligent decisions and take actions and control the environment instead of the labor-intensive operation that exists today. And then at Smarts, we focused on one side of that, of doing root cause analysis. And we focusing on specific area, as I mentioned earlier, on the networking side. In Turbonomic, I shifted and I trying to build a system and we try to figure out, okay, what is a good state and how do I keep the environment in a good state and what is the definition of a good state? And build a system that automatically try to continuously keep the environment in a good state. But really, when you think about how do I really need to operate the environment, it has to combine the two together. First, you have to know what is a good state, then figuring out, am I in a good state? And then if I'm not in a good state, what is the root cause of why I'm not in a good state and how do I get back to a good state? And that's really what we are doing here in Causal. We are kind of saying, okay, let's build a system that capture and understand what is a good state. And when I say about good state, or I call it a desired state, a state in which all the application in the environment are delivering on their objectives while satisfying the constraints in which they have to operate within. So understand what is a good state, be able to capture it, be able to identify when you are in a good when you are not in that state. When you are not in that state, identify or understand why I'm not in a good state, what is the root cause, and be able to remediate and get you back to a good state, and even do better, trying to predict what may get me out of that good state and what actions can I take in order to prevent me from getting out of a good state. So building a system that understands all of those dimensions of what are the objectives, what are the constraints, define from there what is the desired state, and then a system that continuously trying to keep you in a good state, and when you get out of a good state, identifying the root cause of why you are not good, pinpointing why you are not in a good state, and remediate and get you back to a good state. And that's what Causal is. So from on a personal level, it's taking the entire journey that I had for the last 30 years and bring it to a single system that does everything that I was envisioned doing in the last 3 decades.
Well, the interesting thing is that even in the story of what Causal is doing, it's like 4 startups in one. Like, because each layer of what you're having to do to reach the objective that Causal is aiming for requires solving an incredibly complex problem. Number one, with just how do you even instrument the environment, and do so in a way which doesn't impact the environment. because one of the biggest problems we saw in the early networking days was, hey, great, we'll put span ports on everything, we'll measure all this stuff, and then the number one cause for network outages was overload on ports, because we were actually sending data to 10 different places, trying to do analysis on it, but it was overloading the network in doing so. And the same thing happened with a lot of the agent-based systems where, great, I'll deploy agents, but then my agent uses 80% of the CPU. And so it would be the first thing to shut down. So instrumenting and gathering the data has always been a challenge, especially with earlier systems which did not have API endpoints. They didn't have OTel. They didn't have gRPC. They didn't have other ways that we could instrument. So let's talk about finding the current state as a first problem.
Right. So first of all, you are raising a very important problem, which is the level of instrumentation and what information do we have, or what data do we have that we can collect. Now, I would say that before I go into answering directly what is the current state and part of the problem of IT operation is that we actually siloed that over the years. To your point earlier about the networking, or every piece of technology was instrumented in a different way. And every function that we wanted to provide was provided by a different tool using some part of the instrumentation. So we ended up with this nightmare of collection of tools that actually don't have a common semantic and a common understanding of what is being collected and what functions are being performed. And as a result, you end up with a lot of tools, and the only way to bridge between those tools is with humans, i.e. with a lot of labors and a lot of humans looking in those different tools and trying to bridge and understanding the relationship between all the things that is being observed. So really to answer your question, so yes, we have a fundamental first order of problem is, okay, what data can I collect? And today, especially the space that we are tackling, we see more and more, in the days of the networks, luckily we standardized at some point around the SNMP. So the instrumentation of the network was kind of easy, relatively. When you move to the application, it becomes much more complex. But nowadays, especially again in Kubernetes and other areas, you have some native Kubernetes, cloud native instrumentation. You have things like eBPFs that are emerging, and most importantly, open telemetry. But the most important part of what we are doing here in Causal is we are decoupling. You started by saying this is a big problem. Yes, but you have to break it and decoupling it. We decouple the instrumentation from the rest of the system of what we are building. And the way to do it is by starting with what I keep calling the right level of abstraction, on the right modeling of how do I look at the environment that I'm managing, how am I going to represent that environment, and on build an analytics on top of that abstraction. And under that abstraction, mediate that abstraction with the instrumentation that is available to us. And by doing that, we are decoupling the instrumentation problem, which is a problem, I'm not underestimate that problem, from the rest of the value of what you need to provide in terms of analytics and insights and reasoning and control that you want to drive.
Yeah, I think this is the number one. The other thing that people often ask is like, how much data do you need in order to then really truly observe behavior and then be able to make intelligent decisions? And now this is the volume problem, but not just volume, but volume signal v noise, right? So we could have a volumetric amount of data, but it isn't necessarily the right data.
Right, and that I believe that's actually goes to what I call the bottom up versus the top down approach. Part of the issue, or a lot of the problem, starts with the fact that the observability space in general, for years, for decades, regardless of what domain of technology you are dealing with, takes what I call the bottom-up approach, which is, let's collect this data, let's collect this data, let's collect this piece of data. I can trace this, I can monitor this, I can collect this log. Let me take all of this data, bring it to some system, and then I'll figure out what to do with this data. And when I'm collecting the data, when I create the SNMP trap, or I create the log message, or I create this metrics that is being monitored and being trained, there is no thinking about the purpose. There is no thinking about what will we actually do with this data. Someone thinks that this data might be important, so let's collect it. And that ends up with a flood of data, a flood of alerts, because if I'm collecting metrics and logs, then I want to alert about anomalies. But if I'm collecting so much and I don't actually know what the purpose is, I'm creating also a flood of alerts, and that creates the data problem that you are mentioning. My approach for years, for the last 30 years, is to look at it the opposite way, or taking the approach that I refer to as a top-down approach, which says, let's put aside what data, we'll get to the data later, but let's start with the purpose. What do I try to accomplish? What do I trying to get out as a solution? Whether it's, if I want to do root cause analysis, what failures do I actually have to pinpoint and act on? Or if I want to keep the environment in a good state that the application are performing, what actions do I have to take in order to make sure that the applications are performing? Let's build an analytics that's able to give me those answers. That analytic should be built on some level of abstraction that enable that analytics, and then saying, giving that conclusions, those insights that I need to get, what is the data that I need in order to be able to get to those conclusions, to those root causes, to those actions? When you take that approach, you actually make the problem of data much smaller, because then you are kind of laser focused only on the data that you actually need in order to drive the insights, the actions, the control that you want to drive. And that's the approach that we took at Smarts. That's the approach that we took at Turbonomic, and that's the approach that we are taking here in Causal. And it may sound trivial, but it's actually a game changer in terms of the amount of data that you are collecting and the value that eventually you are actually provide. Because at the end of the day, that's the only way to provide a solution that actually provide value to a human, rather than a collection of tools and for the human to figure out what to do with those tools.
Yeah, and this is there's always this interesting barrier where same thing with self-driving. So people say like they're worried about self-driving cars. I'm not worried about self-driving cars. I'm worried about self-driving cars in conjunction with human drivers. The humans invariably are the ones that are going to be the problem. But when we get into IT operations, the one thing that we have is, number one, IT ops people particularly have an incredibly high pain tolerance. I don't know why we do this. We torture ourselves with the amount of things that we look at, the amount of things that we believe that are artisanal, but they're not. Like I believe that I am in control of way more than I am. And then the problem then becomes a trust factor of, that's why people want to collect a vast amount of data, because they think if I have more data, then I can make more informed decisions. But in fact, I would believe it's actually the opposite, that they can't make informed decisions because they've got too much information in front of them to try to derive an actual intelligent result.
Yeah, I mean, I believe that's an illusion. I think that people feel comfortable with the data, but I like to say observability is not control. And not being blind doesn't make you smarter. So yeah, we need data. I'm not saying we don't need data. The question is how much data? And if you don't know the purpose, you end up with a lot of data. And I think that this is a level of comfort that people are getting, but it's an illusion. And really what you want to start with the question is, what do I need to do? What do I need to understand? What insight do I have to have in order to be in control? What do I need to do to be able to control the environment? How do I make sure that I know what is the state that the application will be performing? And what action do I need to take in order to make sure that the applications are performing? Okay, once I know that, then I'll figure out what data do I need in order to get those insights. But just getting data and trend the data and generate reports on that data and monthly look or weekly looks or daily, looking at daily or weekly and saying, oh, did I perform well? I don't see the huge value in that.
The interesting thing is that you have to solve the observability problem to then get to the decision automation, which is like you continue to have to resolve this problem that the industry is stuck on. So I'm always curious, how do you feel that you can move the needle beyond where people are stuck?
Again, we're starting with the top down, starting with the problem and the purpose that what I'm trying to do, and then instrument it with the data that I need in order to solve that problem. And that will leapfrog the issue of the data. I wrote years ago that I said IT operation shouldn't be a big data problem, but we are making it a big data problem because we are taking this bottom-up approach. So the way to get out of that, the journey to nowhere, if you want, is to start with the purpose. I have this purpose to identifying to pinpoint those failures. I have the purpose of figuring out what actions do I have to take in order to make sure that the application is performing. Okay. Build the right analytics, because it all has to be driven by some intelligent, built-in intelligence, and then figuring out what inputs that intelligent inference needs to take in order to be able to drive the insights and the conclusions. And that's my entire, if you want, my entire career in the last 30 years is focusing on that.
But it's, I think I remember you hearing it.
I mean, I'll go back for a second to the days of smarts. I remember, you remember some of you, I don't know if everyone remember the SNMP MIBs that exist, and the SNMP with all the traps and all the attributes. And at Smarts, we provide solutions that work with thousands of different network devices. And people used to ask me, customer used to ask me, how do you deal with all the MIBs informations that every device had its own MIBs and different MIBs and whatever. And I said, I don't care. I don't care about those MIBs. There is a specific piece of data that I need, specific piece piece of attributes that I need to monitor in order to figure out what I need to figure out. The rest, I don't care. And the same goes in turbonomic. In turbonomic, there were products out there that monitor about VM, 600 different attributes. And we integrated with those products, but they said, okay, how do you deal with this attribute? I said, I don't care about this attribute. I care to drive this decision. And to drive this decision, I need this attribute and this attribute and this attribute. Full stop. And that's it. And the same goes here now in the space that we are playing now. There is a lot of data out there. There is traces, there is so many pieces of information that you can collect. The question is, which part, what information out of what's being collected already do you actually need to drive the conclusions that are meaningful for, if you want, the continuous operation of an environment and continuously controlling the environment in a state in which the applications are performing. And it turns out that you don't need so much data. You may need those, by the way, you may need this data for other purposes. I am not saying to anyone, don't collect this data, and maybe this data has purpose for other things, which I don't deal with. But when I talk about the purpose of what we are focusing here, how to control the environment in a state that it's continuously, the application continuously, all the applications continuously deliver service, performing in a reliable way and satisfying a set of constraints that they have to operate with. I'm focusing on that. I'm focusing on the data that enable me to get the insights to be able to deliver on that purpose.
I think then this brings the interesting question of what's actually the most important piece is not the data, but the relationship between resources, which are represented by data that we're instrumenting. And this is where I think observability is, they call it correlation between, sort of the four pillars. That's fantastic. But I still firmly believe that there's so much missing that they're very narrow in what they're trying to solve. What's interesting is that you seem to really, really be going at this highest level of understanding the relationship between all these resources with the least amount of data required to derive an intelligent understanding and then ultimately drive towards decision. And you can't make a decision without an understanding of the relationship to other resources, because any decision made without, it's like the game of life. If you can only look at the squares around you, you're not interacting with the system, you're interacting with your locality within the system. And that's the risk I think that observability gets trapped in, is that we see one point problem and then we throw people at that mini section of the environment, not understanding the relationship to other resources.
Right, and it's even, the relationship are even deeper. It's not enough to just understand that A depends on B and understand those relationships. The key understanding the key thing that you have to know is what we call the causality relationship, the cause and effect relationship. It's not enough to say, oh, this application is running on this pod, and because of that, everything that I see in the pod is causing things in the application. That's not necessarily true, because some things that happens in the application may cause things on the pod that affects other application that runs on other pods. So understanding, not just, sure, obviously you need to understand the dependencies, what I call the entity relationship dependencies, but more important, you have to understand the causality relationship, the cause and effects of things between things that may be observed and things that may not be even observed, but how a failure in one thing will propagate and cause what we call manifestations, things that are observed in other things. And those are not, so just understanding dependencies between entities will allow you to do some level of correlation, but that doesn't necessarily enable you to understand causality. And the key to solve the problem of root cause analysis, which in turn enable you to think about the actions, the automatic remediations, is understanding causality, cause and effect relationships. And by doing that, if you feed it to the right inference engine, you can pinpoint the root cause, and from there you can think about remediation.
Well, and I always think of my example that I heard of one time is there was a study that had come out, and the result or the headline of the study that people grabbed onto was that long distance running increased rates of cancer. And that in itself, it was a true statement based on the data that was born from the study. Except, of course, that if you actually look at what was in the study, was marathon runners have a higher rate of melanoma. Well, if you look at it, and it's in the micro, of cause, of course, they're exposed to outdoor sunlight for hours and hours a week, more than the average person. So it's not in itself, but that running was the cause of cancer, but the behaviors that led them to be long distance runners created an environment in which other causes would trigger cancer. And we get stuck in this, that it's so easy to look for the closest, most obvious headline, whether it's right or not, but just say, this looks like a cause, pat on the back, operations team says, let's reboot the system and go home.
The Bible for all of this is the book, it's called The Book of Why by Professor Yehuda Perl. He invented, he's a Turing Award professor from Columbia that invented Bayesian networks. And he wrote in 2016, I think, if I'm not mistaken, The Book of Why. And he gives a lot of examples along the lines of this example, where basically correlation is not causation. Right. And you need to not understand causality. You need to understand causation in order to build the right system that can control an environment. Correlation won't get you there. And to be honest, a lot of the observability space is falling into the traps of correlation rather than understanding causality. And causality, then you have to ask how much of causality can be learned versus how much causality has to be structured and provided to the system. And that's exactly the space that we are focusing on.
Why today? And what's different today technologically, maybe, or even just human environment? Why does today work better than perhaps 10 years ago in the way that you're approaching this problem with Causally?
I don't know if it works better, but the need is I used to say it in Turbonomic as well. There is some kind of a perfect storm that you have the increased need and the increase of enabling. So on one hand, you have a huge need. The complexity, the scale, the dynamism of the environments keep increasing. So there is a huge need for system to do what we were able, or kind of, I like to say, got away with human doing it. So there is this tremendous pressure to increase your agility, your speed, and you have to do it in environments that are much, much more complex, much, much more dynamic, and the interdependencies between between components become much more complex. Just moving, for example, from a monolithic application to microservices increase the complexity and the dependencies dramatically. The good news that while this complexity and needs increases, the enablers are there also becoming more available, especially when it comes with operating on the environment using software. If you go back to the days of the networks, okay, or the physical host in the environment, where at the end of the day, a human needs to do something physically in order to fix a network connection or to provide a new host, then the speed of how quick you are pinpointing issues or how fast you are able to analyze a situation becomes insignificant or less significant relative to the actual physical time to fix the problem. But if you have now enablers that everything can be fixed via some software command or a bunch of steps in software, so the actual action is seconds, then it makes it an enabler to, okay, I can do it in software, so let me do the heavy lifting, the hard part of analyzing and figuring out what do I need to do also in software. So I have the enablers to act fast. So you have the need and the enablers coming together to create an environment that is ripe for the type of software that solutions that we are building in Causal. But I would say, honestly, this is not, I don't know if this is not a new problem. We are, as I said, I feel like in IT operation, we are struggling with the variations of the same problem that we struggled 30, 40, 50 years ago. Yeah, they had different artifacts. We dealt with it with less of fancy user interfaces, but we dealt with the same issues. And we were, so I don't think that it's a new problem. Obviously, the technology is shifting, so it's new domains of technologies, but the fundamental problems actually didn't change. On a personal level, I would say, as I said to you at the beginning, I focused on root cause analysis in smarts, and then I focused on a different side of the equation in turbonomic, i.e. about how to control the environment in a state in which the applications running on VMs are getting the resources and maintaining the level of utilizations in the right level or in the desired level. And what we do here is actually bringing it all together, because I realized that it's not one or the other. You have to have a system that does all of it. It has to understand what is a good state, understand when you are not in a good state, figuring out, pinpoint the root cause, figuring out what actions will keep you in a good state and what actions will get you back to a good state. So we are actually, my sense is that it's a journey that actually I'm bringing, as you said, maybe 3-4 startups to a single company.
Now, interestingly, the question then becomes, what's the outcome? So what do we now? We've attained causality. What do we do with that information now, or what's the differentiator to that person that's using causally or approaching this problem in this way? What do they now go with this information and take action against?
So, okay, ultimately, I hope that we'll get to a place where we let the software act. And the software do two things. A, continuously trying to act on the environment and keep the environment in a state in which you are in the good state. And when you are out of a good state, as I said, automatically pinpoint the root cause, but also automatically remediate, i.e. bring you back to a good state. So that's the ultimate hope. But that's a journey and we are not there. So what the human do with Causally today, it's putting the human, if I want, in control in terms of having the right insights and understanding, pinpointing the root cause. Maybe he let us to act on the root cause, or maybe he takes the root cause, and because he knows the root cause, he knows what the action, or we tell him what the action. So the bottom line is, even today, before we reach the ultimate goal of where we want to go, the advantage or the what the user get is what the usual things that are, quick resolution, faster resolution, no firefighting, the all automated, the troubleshooting become a zero time process, reducing it from days, hours, minutes to seconds, and with no finger pointing, knowing who is the person that needs to deal with it. And yes, and the actual remediation, the human's still doing it, but it gets to the remediation much faster, and by doing it, avoiding loss of revenue, delivering a smoother service, better experience. What we all trying to accomplish in IT operation. At the end of the day, I always say IT operation has one goal. IT operation exists, IT people exist in general for one purpose, making sure that the applications are performing with no disruption and in a reliable way. And that's what you're getting with Causally today, and really accomplishing it by minimizing or reducing completely the time of troubleshooting and firefighting.
So a question about what people building applications say they're doing versus what you're seeing in practice of how it actually is. We thought that like Kubernetes, or I'll say it was often said that Kubernetes would upend the need for traditional virtualization in the same way that virtualization would have upended physical, not in the same, it's a very different step, but there was the very strong proponents for cloud native sort of said that we don't need single, monolithic machines anymore because this is the way to develop all new applications. But what I've observed is that it's only a percentage of total applications that are actually going to be suited for that type of environment. And so you've got these multimodal application patterns. What are you seeing today? And also, we can look back, since the 70s. Have we always been multimodal and will continue to be so?
The short answer is yes.
Yeah.
I don't think that, first of all, you need an organization, an enterprise need a trigger to transform from one model to another model. It's not just because the new model is a nice shiny toy that everyone will go there. That is a lot of effort. If you go to the big enterprises where they have 3, 4, 5,000 applications, nobody sits there and says, oh, I'm going to transform all my 5,000 applications from COBOL to microservices. So you end up in a big spectrum of different types of applications, which is a huge challenge. That's so that look. In Causally, we not focusing on the other on all applications. So I cannot even go, as a result, I cannot even go to any enterprise and say, oh, but get Causal and get rid of, and all your problems will go away, because you have to focus somewhere, and we decided to focus on microservices, cloud-native microservices. That's where we are focusing on our value proposition. But yeah, I mean, there is environments will continue to be heterogeneous in multiple dimensions, and which makes it very, very complex. And that's why this is, IT operation was never simple. And I'm not saying that I have a magic bullet for IT operation. IT operation will continue to be a drag, if you want.
So then this becomes an interesting. This is both a startup challenge, a company building challenge, and even a life challenge. How do you build belief? You've been very good at this over time, Shmuel, in that you've been very fixed that don't get distracted by the things that we see as small goals and small gains, that the biggest goal is always the goal that you have to believe in and work towards. We find iterative steps along the way, but I watched this happen. I think it was employee 200 or so, and I saw incredible growth and changes in the organization when you and I were together, and the industry. And how do you do that now? Again, here we are. It's like you did it through Smarts, you're doing it through Turbo, you're doing it now with Causal. For yourself and for others, how do you build and maintain belief?
Well, I always position that as a journey. It's not like here is a silver bullet for all your pain. I'm trying to be brutally honest on what can be done, but staying very, very, very focused on the ultimate goal, if you want. At the end of the day, we have to stay very focused on, especially when it comes to, I'm playing in one little pond for 30 years, which is if you want, IT operation, IT management, software management. And in that space, we have to stay focused in trying to figure out how do I reduce the labor associated with IT operation. And staying focused on that question and build everything that we are building from that vantage point of, okay, what I'm doing this, if I'm going to provide this, is that going to reduce some element of labor associated with IT operation? And if the answer is yes, then it's worth doing. If the answer is no, then I prefer not to do it. And trust me, there is a lot of products out there that maybe look good, but they are not reducing labor. They are maybe providing better information, maybe providing more data and more visibility to human, but it doesn't reduce the labor associated with operating the environment. So I'm very, 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 very focused, whether it's in the area of root cause analysis, whether it's the area of resource management, whether it's really what labor do I save by doing this? And that's my entire career, is focusing on that one question. Is what am I doing, is what I'm providing going to reduce labor? And I cannot, as I said, IT operation is very complex. There's a lot of dimension to that. So you cannot eliminate labor out of it. But can I reduce it? If I'm able to automatically in Turbonomic, if I can automatically place VMs, if I can automatically resize my EC2 instances, am I reducing some labor? The answer is yes. If I'm automatically pinpoint root cause instead of doing troubleshooting, am I reducing labor? The answer is yes. So it's a journey, and there is no one silver bullet to reducing labor, but I'm focusing on reducing labor. And in the case of Causal, very focused on cloud native application running in cloud native environments, collection of microservices, and so on and so forth.
How do you feel, and are you excited about AI and AGI and sort of we've seen a lot of changes, particularly in the past 5 years in, both on the hardware and software capabilities. How do you feel about where the industry is in the sort of growth and increase in AI and what some people are ultimately hoping is the goal towards AGI?
Look, AI is, who am I to say that AI is not going to change the world? As long as we know what we do, what I don't like is where you ask someone, what do you do? Oh, I do AI. How do you solve it? Oh, with AI. Oh, no, I'm solving it with Gen AI. Or, I think if you have a definition of what you're trying to solve, and then you say, oh, this is how I solve it. And yes, underneath that, I'm using some LLM, or underneath this, I'm using some algorithm that falls under AI. That's great. And I think AI has a huge potential, obviously. I'm not the one to sell you or anyone AI. I think there's some, not I think, I'm sure there's a lot of hype around what AI can get us. Especially when you go about AI generating code or AI doing this and doing that we are years away from. On the other hand, by the way, again, going back to my vantage point, AI actually, those AI systems, those LLM processes will introduce a huge need at some point for a good management system. So there will be a new domain to attack with good management software.
Well, that's the interesting thing, that what often gets lost in these discussions is that we don't eliminate necessarily human involvement. We don't eliminate necessarily other systems. We are simply adding additional, layers or abstractions. But in the end, they're all in the same way that people said, oh, the cloud is just somebody else's computer. Well, yes, but it's, no matter how you slice it, it's still hardware that is run on the software run on hardware that's in a different architectural pattern. We may obscure it, but we don't actually get rid of it.
Yes, if you remember in the days of Turbo, we talked about, I used to say, look, in order for application to perform, at the end of the day, they need CPU, memory, IO, and networks to perform. This supply of resources needs to come from somewhere. So when we ran on-prem, there was a physical host, and then there was a VM. Okay, then we shift to the cloud. We say, we don't have to worry about it. No, you still have to have this supply, and you have to match your demand of application for resources to the supply of those resources that happen to come from the cloud. You just shifted, the problem didn't go away. So the same thing here. So you have layers of LLMs running on, you still have to manage it. You have to be able to, and let's not think that, some magic will happen and the LLMs will manage themselves. I don't see that yet.
What's the opportunity to add human knowledge in order to affect or like change inference down the road? Like, let's just say that we have a bespoke custom application inside an environment, and the system itself may not necessarily look like, so there's application and human knowledge in what the application's supposed to do, and then how it behaves. That doesn't always represent itself in the system. We don't necessarily monitor. There's not a monitorable outcome. So, or we can say like, I know this is the behavior of the application, and so if I do this, it will get better. Can we then influence causally, or ultimately influence the observation of it to say that, look for this as well? That may, like, I'm just trying to think of like where can we add that human capacity that I think is what's really why people don't trust just pure systems generated analysis.
Yes, I think so. Okay, put aside causally for a second, then I'll get back to causally. In general, you're right. I believe if you look at the LLMs and whatever, the only interaction with LLMs is human provide some knowledge. The prompts, the human provide knowledge to the system, and the human provided knowledge derives the analytics that eventually the LLMs or the answers that the LLM gives you, right? So I believe that those prompts give an opportunity for human to bring their feedback into the system, right? And the same true in causally. I mean, to begin with, we start causally. One of the things that I believe strongly right now, and it may change in a few years, but right now, you cannot let machine just learn causality from scratch, just from data. I think that there is an element of what I call structured causality models that has to be fed as input to the system. So our starting point is that some structure of causality that we feed into the system. And that structured causality can be refined maybe by the machine, but also by a human. So there is place in causally for a human to put their knowledge in terms of what is the causality and how things are propagating. And again, this is an opportunity to learn, but it's also a place where human can put their input.
Yeah, and I think because that one of the classic cases was, I think at the early VM days was said, yeah, vMotion comes along, everybody thought this is heroic, it's fantastic. It was interesting. It was an amazing thing at that time, still is, and what it can do. But then they said everything can move, and then all of a sudden we started to see problems where SQL servers, that no matter how down to like sub-second, transfer points when it does the final in-memory copy to the new host, there's a point where it stuns the application. 90% of applications survive the stunning for that microsecond, but SQL servers did not do well. Some did, some didn't. And so what we would have is one person would say, don't ever move a SQL server. And that becomes, this is the problem of causality with human brains, is we think, if I do this, a bad thing could happen. I'm never going to do that. You're like, no. Let's actually get further into the analysis of what the real cause is.
Right. But to your point, I mean, so a human went and say, don't move this SQL. Ideally, a machine can learn over time based on experience not to move that SQL. But those are places where human can improve the behavior of the system.
Right.
But again, what's important, I think, is to distinguish between human improving the behavior as a reaction to something that happened right now versus human declare a priori and control a priori what should be the behavior based on their knowledge. And that's a different.
Yeah, I don't think of it, and this is one thing I took from you, is that rules, don't think of it as rules, but constraints. And I believe that like adding human interaction creates what I would think of as a soft constraint, that if it would be preferable not to move this, but in a case of ultimate emergency, we can do this. The idea that we can gently create constraints that would narrow down what the optimal response would be.
Yeah. At the end of the day, and that's actually what we do in Causal. It's like, I believe that, to your point, the ultimate solution is some combination of root cause analysis solution together with constraint resolution. And the constraint resolution enable you to define the parameters, if you want, in which you have to operate, and let the system figure out, okay, what is the right configuration that satisfies those constraints. And some of those constraints, which is something that could be what I call the hard constraints, but to your point, some of them can be soft constraints, because at the end of the day, I used to say it in the turbonomic days, every constraint has a price. Because, I can say, oh, I need this level of redundancy. Okay, why? Because if I have a failure, it will cost me $1 billion. Okay, but if the cost of providing this redundancy is more than $1 billion, maybe I'm ready to take the penalty of $1 billion if it happens, right? Yeah. Or maybe even so there is some trade-offs that I have to figure out in order so it's always a trade-off, right? We are in IT, in life in general, but definitely in IT. At the end of the day, we are managing trade-offs and very complex set of trade-offs, and that's the essence, if you want, of what you manage. And those trade-offs can be defined at some level by human, but to be honest, a lot of those trade-offs are beyond what human can actually specify and articulate. So those trade-offs will have to be figured out by machines.
And also the fact that trade-offs are very much point in time based. There's a set of elements that could change, that could actually eliminate that particular trade-off. And this is the human intervention problem, is that we say, hey, don't ever move the SQL server because it will go down. And then 10 new things come along that solve that problem, but yet we put this hardened rule in place because I remember the day that it went down and I don't want that to happen again. And that's, I believe, where
I actually would like humans to interact at a much higher level with the system. My vision here is that a human will say, look, I have this set of applications, and maybe I'm going to an individual application, but let's say I have an environment with these sets of applications. This set of application has those objectives in terms of latency, response time, number of transactions that they have to serve, and they have a set of constraints in terms of what do they have to comply with and what is the budget. And that's the level of interaction that a human define, and the rest in terms of how these applications needs to be configured, deployed, move around, scale up and down, all of this automatically is done by the software. And if you get to that stage, Yes, so you have, the human has knobs of control, but those are very high level knobs of control. Right. And it doesn't need to get to the minutiae, if you want, of, oh, the CPU utilization needs to be at this level, or the CPU limits needs to be at this level, or move this, be allowed to move the SQL database or not. This will be figured out by a system giving your goals, giving your objectives, and giving your constraints.
I love it. I love it. I wish we could. I could do this all day. And Shmuel, thank you so much. And we're gonna wrap for this one, but I will definitely point people. Causally is. I'm really excited by what you and the team are building, and I'm looking forward to. We're gonna keep revisiting this because I want to see the progress and. I'm excited I'm very proud of what you continue to do and watching the impact you have both on people that you work with internally, and I've seen it on the customer side as well, and you do create a genuine positive impact. So it's a pleasure to watch it occur.
Thank you. This was, thank you very much again. You're very kind with your words. This was a lot of fun, and anytime you want me to talk to you again, I'll be happy to. This is really fun. And we can talk about other things, not just Causally.
That's right. Yeah. No, definitely. There's so much more. I wanted to make sure that we really explored this because I'm excited by this. So again, Shmuel, thank you very much. And for folks, of course, check in the show notes and we'll have links out to Causally. Absolutely worth a watch and looking forward to much, much more in future.
Thank you so much.